Yes, I'm audible to you.
Yes, sir.
Yes, last day we have discussed chemical kinetics.
Yes, sir.
Last topic.
So last topic was our RNAs equation.
Let me start basic. Introduce yourself. Then we will discuss.
Hello, sir. Good afternoon. My name is Poulami Ghosh. I belong to West Bengal from the district Hooghly. I have passed my 10th board exam on 2024 from under the West Bengal Board of Secondary Education with 86% marks. Then I have passed 12th board from under West Bengal Board of Higher Secondary Education with 85% marks. Then I have repeated 1 year for preparation of medical exam. Then I have joined graduation and I have done my BSc in chemistry from University of Calcutta with 73% marks. And then I have done my masters from Central University of Punjab and passed out in 2022. And I have qualified JAM 2020 and I have qualified GATE 2023.
Yes, good. Let's move on. Today topic is chemical kinetics. Chemical kinetics topic is catalysis.
Yes, sir.
Yes, what the main application of catalysis? Explain.
Sir, catalyst are the substance in for its presence, which enhance the rate of reaction without consumption of its in the reaction, which is known as catalyst. And catalysis is that to enhance a reaction in which it may be the lowering the activation energy, which the effect in the rate of reaction.
Yes. What the relation between in catalysis in activation energy?
Sir,
Yes, yes.
so this board is visible. You can see.
Yes, visible, yes.
Sir, for a normal reaction, we know that the energy and reaction coordinate. So for a normal reaction, reactant goes to product where this amount of energy. It is without catalyst. In presence of catalyst, the activation energy required will be less, which is this.
What will be the effect of reaction rate in any equations?
So in presence of catalyst, the rate of reaction will be fast. The time taken is will decrease, but the amount of reactant and product do not affect by the catalyst. In a process, catalytic process, the catalyst may consume or it will regenerate in the whole process. So in the rate effect, the rate of catalyst does not appear in the rate equation.
Yes, good. Next topic is steady state approximation. What the main basic application of steady state approximation?
Yes, Sir, steady state approximation is applied for the reactive intermediates in a consecutive reaction. If which is that if A is converted in B and then it goes to C. So here B is the intermediate, and if steady state approximation is tells us that the rate of formation of B is equals to the rate of disappearance of B. That means the rate of the concentration of B is constant. So in this case, like if it is K1 and K2, then we can say that dB/dt is equals to 0. So in some point, the rate of formation of B will be equals to rate of deformation of B. So here the equation applying steady state approximation on B, we can write the equation like if the equation of it is K1 and this is K2, then it will be like this. The K1 of A will be equals to K2 of B.
Yes. Steady state approximation.
Sir, graphical representation.
Yes, steady state approximation in limitation. Any limitation?
Sir, if the intermediate is not that reactive intermediate, then we can't apply steady state approximation in this case. And in the beginning of the reaction, the rate will not be equals to the disappearance rate. So this is a limitation. We can calculate it. We can apply it in a specific duration of the time of the whole reaction happening.
Yes. What is equilibrium approximation?
Yes, sir. Sir, equilibrium approximation is that in some point, sir, if A and P is in equilibrium, then after some times, when the the rate of forward reaction will be equals to the rate of backward reaction. In that case, we can't see any change in the reaction is happening. So if this is concentration versus time, then we can see that if this is the reactant will be like this, and the product will be like this. In a point, the concentration of A and B, here it is A and B, is equals to, this will be parallel to the parallel, and it is, you can't see any effect in the reaction.
Yes. What the difference between steady state approximation and equilibrium approximation? Difference.
Sir, for the equilibrium process, it is like the B is means the product is converting into the reactant, which is the backward process, and for the steady state reaction, it is the example of consecutive reaction. For this, it is converted into some other species, not in the reactant. So for this, we can identify the intermediate in this case for the steady state approximation.
Yes. Next point is Lindemann theory. What is Lindemann theory?
Sir, so Lindemann theory is, we know that In a reaction, the two molecules come close to each other, collides, and then converted into product. So after collision, the molecule may be molecule first activated, and the activated molecule have two ways. Like the two molecule of A come close to each other, then one molecule is activated. So from the activated, there is two ways. One is like the deactivation. The activated molecule can deactivate, or it can goes into product. So in some if we vary the pressure, then the proportion of deactivation and the converting in the product, or that means the decomposition, will vary. So for low pressure, in the case of low pressure, the activated molecule decomposes and it converts into, it forms the product. And for the high pressure region, it will be deactivated into the reacting molecules. So Lehman theory, by if we calculate, then we can see by graphically that in low pressure region, the rate will be like the order of reaction will be 2, and the low pressure order will be 2, and high pressure region the order will be 1. So if we show it graphically, then it will be uh,
Yes, graphically representation of Lidman theory is rate versus concentration and concentration versus time. This type of graph so by the Lidman theory.
um, the rate versus time.
ये लिंडमैन थ्योरी का जो फाइनल प्रोडक्ट आता है वो पता है आपको क्या आएगा फाइनल प्रोडक्ट? फाइनल प्रोडक्ट जो आएगा उसमें अगर लो प्रेशर एंड हाई प्रेशर, देन व्हाट विल बी द इफेक्ट ऑफ द प्रोडक्ट?
So in low pressure, the decomposition will be higher. So if we calculate it like the formation of product, then we can see like is A star, and A star is our intermediate. So if we apply steady state approximation of A star, so it will be like Sir, in case of low pressure, then decomposition happens. That means K3 with low pressure region at low pressure, K3 will be higher than K2. Then the equation, the rate equation will become the rate will be of a second order with respect to the reacting molecules. And if we consider the high pressure region, then the K2 will be greater than K3, and in high pressure, K3 is at high pressure. At high pressure, it will be fast order with respect to the reacting molecules. So this is
Yes. Low pressure, what will be the order of reaction?
at low pressure it will be second order, and in high pressure it will be first order.
First order. Why? What the region? Low pressure, second order,
Sir,
and
because
first order.
Sir, because at low pressure the decomposition will be in higher extent, so the activated molecule will decompose. So in that case, the rate constant for decomposition will be higher. So in the rate equation, ignore the we can ignore the rate constant of the deactivation process with respect to the decomposition process. So in that case, we just ignore neglecting the K2 into A5. So after calculating, we can see that R equals to K1 into A square. So we can say that at low pressure region, it will be directly proportional to the second order reaction rate constant. Similarly, if we consider the higher pressure, so in that case, at higher pressure, the decomposition will be higher. So K2 will be greater with respect to K3, and we can ignore K3 part. So after calculating that, if we neglecting K3 from the rate equation, so it will be fast order.
Yes, good. And the slope? Slope, rate versus
Sir, so the slope of the reaction will be K1 into K3, we will consider the rate versus
rate versus concentration,
concentration.
concentration versus time.
Yes, sir. So if you consider rate versus concentration, it will be first order, and concentration versus time, that is first order. So concentration will be exponentially decayed at high pressure region.
Yes, ग्राफ क्या आएगा? शो कीजिए ड्रॉ. There's no problem. You look there. You have to study about it. Yes.
Yes, sir.
Next topic is Michelmanson equation. Michelmanson equation. Yes, what the main application of Michelmanson enzyme catalyst?
Yes, sir. So in case of enzyme catalysis, in case of the in some substrate, the enzyme is coming and we can get the enzyme substrate complex and then it will convert it into product. So if this the rate of formation of product we can calculate via considering the Michaelis-Menten equation. So it is H E plus is the first step, and then is B.
Yes, derivation of Michelmanson equation.
So in this case, yes, the enzyme substrate complex is the intermediate, so we can apply steady state approximation here, and the rate of formation of product is into ES. Agree. So in starting of reaction, F equals to 0, AC is equals to AC, and including we can replace this in the equation. Here. Sir, R will be equals to R max into S divided by S plus Km, where Km is the Michaelis Menten constant.
Yes. Yes, Michael Manson constant. Yes. If Michael Manson constant is Km greater than substrate and Michael Manson less than substrate and equal substrate, what will be the product? What will be the order of reactions?
So if Km is greater than substrate, then R will be minus by Km. Then it will be order will be first order. If Km is less than substrate, then R will be minus by Km. Equals to S. So when Km is greater than the concentration of substrate, then it will be R max into S by Km, which is the first order with respect to S. When Km is greater than S. When Km is less than S, then we can calculate that R is equal to R max, which is zero order. And when the two is equal, then we can say that you can write this the lower part as 2s, and you can say that R equals to R max by 2. So it will also say 0 order.
Yes. And Michael mentioned equal substrate, then what will be the product?
So when it is equal, then R max will.
Yes. And what the slope of rate versus substrate and concentration versus substrate slope graph?
Sir, if we consider R versus A's graph, which is Michaelis Menten graph, curve at the low concentration of A's, then we can neglect it at the low concentration of A's, then the K will be greater than A's. Then we can say that R will be equals to R max by AM. We can neglect A's. So in the lower concentration of A's, it will be fast order. This. And when the A's is greater than at the higher concentration of A's, it will be A's will be greater than Michaelis Menten constant. Then R will be equals to R max into A's divided A's. And it will be 0 order. So in this region, it is fast order with the low concentration of substrate, and the high concentration of substrate, it will be 0 order. And in between this place, we can say that it is a fractional order.
Yes. Any limitation of Michelson equation?
Sir, one enzyme can combine with one substrate at a time. So multi absorption it can't be happen. So if the multi absorption is happened, we can calculate this equation.
Yes. One term used in Michelson equation is how to determine the value of Vmax and linear work method. What the slope of linear work method? Slope. Rate versus substrate.
Yes, sir. Sir, in the line method, bar method, we are calculate that the 1 by R versus 1 by A's. So in that case, Sir, in laminar bar plot, we used to plot 1 by R versus 1 by S, and it is a straight line with the slope will be Km by R max, and the intercept will be 1 by R max. So from the intercept or from the slope, if we know the Michael is Menten constant, we can calculate the R max from the plot.
Yes. Good. Next is what is collision theory? What is the main application of collision?
So in case of collision theory, usually the compounds come close to each other and they need collides and converted into products. So in this case, we know that the postulates are like all the atoms we are considering the molecules are of hard sphere and there is no force of attraction or repulsion present, and the
Yes, who was developed collision theory?
Vanderwaals.
Yes, Arrhenius and Van Hoff. Yes. कॉलिजन थ्योरी अब आज तो हो गया मॉक, कल हम डिस्कस करते हैं। आपका जो पार्ट है, एक तो कॉलिजन थ्योरी, एक्टिवेटेड कॉम्प्लेक्स थ्योरी, ट्रांजिशन स्टेट थ्योरी, इसके मेन रिलेशंस, सॉल्ट इफेक्ट, फास्ट रिएक्शन, स्लो रिएक्शन, पैरेलल रिएक्शन, कॉन्जुगेटिव रिएक्शन, ये टॉपिक लेफ्ट है। बाकी जो कुछ पॉइंट है उनकी आप लिमिटेशंस वगैरह कर लेना, ठीक है। ये लिमिटेशंस जरूरी, जो भी टॉपिक करते हैं उनकी लिमिटेशंस है। बाकी जो अभी है वो मैं लिमिटेशन आपको भेज दूंगा कुछ टॉपिक की, उसे मैंने भेजा भी था आपको पहले लास्ट टाइम।
हाँ सर,
लिमिटेशन बाकी ठीक है, एक्सप्लेनेशन कीजिए, प्रैक्टिस ज़्यादा हो, ज़्यादा से ज़्यादा। आपका इंटरव्यू कब का है, डेट क्या है आपकी?
7
7 मार्च।